Welcome. In our previous lessons, we have gone through series of lessons on the inverse of a function, where we have mentioned that for inverse of a function, to find it algebraically, you must first equate the function to y, interchange the variables, and make y the subject. My name is Nana Yawedu, and you can call me Say Nana. Remember to like this video, share this video, subscribe to my YouTube channel, and don't forget to click on the notification bell so that you can get all videos on time. In this lesson, we want to consider linear functions. We want to look at lines, and we also want to look at things that have constant rate of change, right? So we want to look at what the linear function is graphically, and then we want to look at how we can represent it in terms of algebra. So let's consider these graphs, and then we'll be able to identify the linear functions, right? So when we look at the graph here, we see that there are several linear functions here. So we see ay plus bs is equal to c, which represent the function or the straight line which is in green here. So we can have a function that is of the form y is equal to as plus c, right? And then this will be a linear function, right? Or we can see the vertical line where we have x is equal to p. So for example, x is equal to 2 or x is equal to 3. It's also a linear function, right? And then we also have the horizontal line where we have y is equal to q. For instance, y is equal to 2, or probably y is equal to -3, which could have existed down here, right? So these are all linear functions. So when we talk about a linear function, it's a function that is of the form f of x, right? Is equal to as plus b. So a linear function can be of the form f of x is equal to as plus b. Now we see that, for instance, if I have f of x is equal to 3x plus 2, then we see that the 3 and the 2 are constant, right? They are constant values. So a here and b here represents the constant values, right? So a and b are the constant values. And then we see that the x in the function and the f of x in the function are variables, because we can equate f of x to be equal to y, where we have y to be equal to 3x plus 2. So the y and the x represent variables, right? We can also write a function which is linear in the form y is equal to ms plus c. And in this case, we see that the m and the c are constant, right? So m is a constant and c is a constant, and x and y represents the variables. We can also write the equation form of a linear equation, which would be y minus yy is equal to m x minus x1. So we can write it as y minus y1, which is equal to m x minus x1. And in this case, we see that the variables here are x and y, and then we also have our variables as well, s1 and y1. Now let's consider how we can graph a linear function. So we want to look at how a linear function can be graphed, and we can use a graphing tool, right? This time there are several graphing tools. So we can use a GeoGebra, where we can simply input our function. So let's assume that our function is equal to y, right, which is equal to 2 multiplying x, right, and then plus 3. Now once we do that, we are able to see our line drawn. So we see that the line is drawn very nicely, and then we can be able to identify which part of this line represents our y-intercept and which part of the line represents our x-intercept. So when we look here, the point where the line, right, touches the y-axis is our y-intercept. So we can circle this side, right, and in this case we can say that that is where y is equal to 3. So this represents our y-intercept. And then we can also have the point here, right, which will represent our x-intercept. That is the point where the line or the equation touches the x, right? So we call it x-intercept. So we say that for our y-intercept is the point where x is equal to 0. We see that x is equal to 0 here. So you can write it in coordinate form as 0 and 3, comma 3, right? So 0, the point where x is 0, you realize that y is 3. So that represents our y-intercept, right? We can actually explain this as probably the point, right, on a particular linear equation where our y-intercept begins, right? So in the y part, that is where the y begins, or where the y takes off in a way. So we have the s-intercept, right? So with the s-intercept as well, we can have it as, here we have negative 1.5. So in coordinate form, we can write it as negative 1.5, right? We can write it as negative 1.5 and then 0. So we have y-intercept, and then we also have x-intercept. And we've looked at how we can be able to use the graphing tool to be able to draw our graph and have our graph look very linear, right, when we have our equation written. Now let's consider some of these things that we looked at with the graph. So some things to note with regards to graph of linear function. Remember that we mentioned that the y-intercept is the y-coordinates of the point, right? So as we saw in the graph, is the y-coordinates of the point where the graph of the function cuts the y-axis, right, where the value of x is equal to 0. So we always see that when you have a function, right, in this case we have maybe y is equal to 2x plus 3a, as we do, the y-intercept always is a constant c, right? So this represents our y-intercept, right? So that is a y-intercept. Another way, when we say that our, right, x value is 0, right, so we say it is a point where x is equal to 0. So when we substitute x to be equal to 0 in the function here, it means that we have our y to be equal to 2 multiplying 0 plus 3, and that implies that our y becomes equal to 3. So this represents our y-intercept, right? So when you see y-intercept, that is what it means, right? And there's a point where it's equal to 0. And the value of our s-intercept is the s-coordinates of point where the graph of the function cuts the x-axis, where the value of y will be equal to 0. So when we equate y to be equal to 0 here, we see that we can say 0 is equal to 2x plus 3. And in that case, we have, right, 2x to be equal to negative 3. Then we divide both sides by 2. And then we are able to get our x to be equal to negative 1.5. So you realize that with the graph, we saw that our x-intercept was at negative 1.5. So basically in this lesson, we have gone through to look at what the linear function is, and we've been able to look at how we can graph a linear function using GeoGebra. In these days, technology is very important, so we need to know how to visualize some of these functions using technology, and then we'll be able to interpret them, right? So the important thing is to be able to interpret what each of them means. Remember to like this video, share this video, and subscribe to my YouTube channel. In our next lesson, we'll be looking at how we can find the gradient of a line or of a linear function. See you in the next lesson.